Alright troops, Yoker Uni presents Oh yeah, bottins, botterettes and wee baby bottins. Valdo back again to heavy get torn into some more physics wonders. A bit like Brian Cox, only more gallus.
You would have to be a complete twat.
Yalday. So it's about time we fire into quantum physics and what we need to know about atoms and all that for the all higher physics then, I suppose. Just like people for Livingston, this isn't going to be pretty, but if you're on the ball then you'll get it. Atom, spelled A-T-O-M. The T is silent, by the way. Atom. So atoms are like wee balls. They're actual pure like wee fuzzy balls with no actual edge in that. In the pure middle, you've got a wee mad pure tiny group of one of more smaller balls called a nucleus. This pure has your mad protons and neutrons. Neutrons haven't got a charge, protons have got a positive charge. Electrons have a negative charge and pure fire about mad with it somewhere around the nucleus. The pure brain bash or factoid that you need to get your brains around is the fact that the nucleus is about 100,000 times smaller than the atom itself, but almost all the mass is pure fun there. Mental. See these wee mad electrons? We don't have a scoop where the hell they are, but we know roughly a wee bit, sorta, you know, where they'll probably be and that. You can't just walk up to an atom and go, there's one electron, there's another one there. It just doesn't work that way, man, alright? It just doesn't work. Here's a bit of quantum physics buzz for you then. Some wee mad punter fae party called Rab Millikan was heavy squirting oil about in a big electrical field one day. That's about all you need to know about his pure famous oil drip experiment. Look it up on the intertube if you want to know about it, alright wee man? So Rabbi Millikan pure ended up with some amazing conclusion, which was electrical charge only comes in specific whole number multiples of the charge of one electron, which is pure 1.6 to the 10 to the power of 19 coulombs and that. You can have 2 loads of these, 3 loads, 4, 5, 6, don't need to go on, but you can't pure have 2.5 or 3 3/4 or 4 and a wee bit times the charge, alright? Electrical charge doesn't do fractions. This means electrical charge is quantized, which means comes in pure well defined wee bits and that, alright? Sorted. Same goes for a proton, by the way. Protons and electrons have the same size of charge, but they're pure opposite, so they heavy pure attract each other. A bit like me and the birds in Yoker when I put on the old Paco band or my polo sport. The birds are pure around me like flies on a job because of the pure attraction they have for the Valdo. Luckily for protons and electrons and atoms, a wee guy called Harry Heisenberg and his pure mad unsurety principle pure stops them ever falling into each other. Sadly for Valdo, wee Harry Heisenberg doesn't help you when you're pure getting harassed with the ladies up the boulevard on a Saturday night. Say no more wee man, say no more. Because of their pure mental electrical attraction to each other, electrons should pure fire into the nucleus and stick to it, but it doesn't. Because if it did, we'd pure know where it was. Pure Harry Heisenberg's like, oh you, you. You can't know where something is and what momentum it's pure got exactly. You're going to need to be a wee bit unsure about it. This unsurety value is pure heavy tiny, so we don't ever notice it in our world, but electrons have to keep a heavy edge on it, by the way. This means they can't get too close to your mad nucleus, cause then we would know where it was and also how fast it was moving, but we'd know it a bit too exactly, you know what I mean? So they just fire around the nucleus at pure heavy speeds and some energy values, so we keep our pure unsurety number proper on that, you know what I mean? Told you it was pure mental. Mad Neely Bohr fae Pollock pure said the mad electrons fire about the nucleus in things called orbits. He also pure said that these mad orbits had to be pure specifical values and that each atom had their own set of numbers for these orbits. Like hydrogen atoms have these pure specifical defined orbits here, which pure tells you how much energy a mad electron would have at these orbits around the nucleus. The further away from the nucleus an electron pure lives, the more energy it's going to have. The closer it is, the less it will have. There's a pure reason for this, cause wee Davy de Broglie, who is a maddie fae Denniston by the way, pure said everything has a wavelength and we're all simultaneously waves and particles. What? Pure tripping, ya maddie. Nae danger, ya rocket. We don't ever think about this in the real world though, but down at your mad atom-sized world, electrons are going to have a mad wavelength, which is pure serious, so it is. If an electron was firing around a nucleus at an orbit too close to the nucleus for a certain wavelength, then it'll pure interfere with itself. Easy, tiger. We can't have an electron cancelling itself out, because that would pure violate the universal laws of nature and crap like that, alright? If you want a pure visual of what I'm talking about, think about your local crazy dog when it has a wee episode and starts chasing its own tail and that. What would happen if it catches up with its tail and starts eating itself? That's what I'm talking about. If an electron pure happened to get more energy, then it would have a bigger wavelength, and to make sure it doesn't interfere with itself, it has to get bumped up to the next orbit level for an atom. Right, so these wee mad electrons that pure fire about in these nearly Bohr orbits around atoms have energy. Sometimes they can get energy and bump up to higher orbits. They can pure get this energy for absorbing a mad photon. The mad energy of a photon is pure given to you by E equals hf. And your H is your mad Planck's constant, named after Max A. Planck, man. Stupid name, but a super button. If an electron was to pure get bumped up to a higher orbit, then it has to absorb the exact energy, which is the difference between the orbits. This means a photon has to have the exact same energy to get absorbed, which means there's only one exact frequency for a photon that's going to do this. Bigger jumps to higher orbits just means bigger frequencies for your mad photons, but they still got to be exact values of hertz, you know what I mean? Turns out if your mad wee electron is pure in higher energy orbits, then every now and then they'll get pure heavy bored and just go, nah, see you later, I'm away back down to my lower energy orbit, and does a pure bunk. When it does this though, it loses energy, and this is pure geed out as, wait for it, a photon. The pure emitted photon has an exact frequency matching your mad equation E equals hf for the exact energy the electron's lost. K, wait for it, peace. So what exactly does all this crap mean then? Well, lasers pure work by having electrons already excited. That means they're pure in high energy orbits already to begin with, referred to as a population inversion. A wee mad photon comes along and it isn't getting absorbed, so he's like to the wee mad electron, here you, ya button, coming out to play. And the wee mad electron's like, aye, hold on. So it pure drops down to a lower orbit and fires out a photon. So a wee mad photon stimulates an excited electron to drop down and give you another photon. One photon makes two photons. Then they can go off and fire about and stimulate another two photons to get popped out. Then it all pure snowballs, and before you know it, you've got heavy hundreds of billions of photons. And that is your mad laser beam. Lasers only have one colour, so all your mad stimulating and emitted photons are all the same frequency and crap like that, alright? We call that coherent, alright? Bigger picture now then. Each atom in the periodical table has its own unique set of electron orbit levels and stuff like that, right? This means each atom has its own unique set of frequency of photons that can be pure emitted or absorbed. If you look at all the mad frequencies an atom can pure give out, then this is called your mad line spectrum. If we look at all the mad frequencies an atom can pure absorb, then this is your mad absorption spectrum. The wee mad lines pure match up because you either give it out as light or suck it up as light when you absorb that frequency, you know what I mean? Anyway, here's a wee mad random made up set of orbits for a made up atom, alright? Your mad lowest energy orbit is called your ground state and labelled E0, and then you go up E1, E2 and all that. There's a mad orbit level called ionisation level. See this one? See if your mad electron has the exact energy to get up to this level by absorbing a pure high frequency photon, then it will technically leave the atom. Losing an electron makes an atom turn into an ion. If you pure hit an electron with an even higher frequency photon, then it will have energy to get to the ionisation level, and it'll have a bit left over, which you pure see as kinetic energy, and the wee electron's like, yes man, y'all day freedom, I'm out of here, see ya losers, yes. And then it goes off to contribute to some photoelectric current somewhere or whatever, alright. That's why only UV light gets electrons off a zinc metal plate and no regular coloured light, you know what I mean? Only UV light has a high enough frequency to heavy get electrons up to ionisation level. Blue light doesn't, alright? we pure use the absorption spectra to heavy figure out what stars are made for, because the cool gases in the star's atmosphere are going to absorb some frequencies of light depending on what the star's made for and that, you know. So we see these wee black lines where the frequencies didn't get out and were actual heavy absorbed. One wee bit of mentalness for you to finish with then. See windies, right? See the light that comes through the sun? It doesn't actually reach us through windies. What actually happens is the wee mad electrons inside the atoms of a windy absorb the photons of light, so they get bumped up to higher energy orbits, then they drop back down and give you a photon. Then the next wee atom along for it absorbs that photon and then a bit later drops down and emits another photon, and so on and so on. So what your eyes actually get is the photons emitted by the last wee layers of atoms of the glass in your house windies, alright? Is that no just pure mental or what, man? This is what to do with your mad QED, man, your mad quantum electrodynamics. And it's at this point Valdo bows out and heads up to the bully with my mad Links Africa on. Yaldi. Don't have nightmares, wee man, about quantum physics and atoms and crap like that, right? It's heavy actual a doddle. Catch you Versace.